Hello, Miss. I'm Nushahira binti Sauji from AS120C. My group will be presenting about application of differentiation by solving min or max problem.
Hi and greeting Miss. I am Nurul Najwa Nashira binti Yusuf from AS120C.
Hi, I'm Nurul Azmina from AS120C.
Hi and greeting Miss. My name is Nur Atika Shahada from AS120C.
So I'm going to talk about the introduction. The Majlis Perwakilan Pelajar of UiTM Samarahan (MPP), they received a report regarding the volleyball court. The report is about the insufficient area for students to play. The volleyball court is usually conquered by the male students, and that is why the female students did not get the chance to use the court. So as a society that represents the students and their aim is to help in student welfare, they are taking serious. After several meetings been held among the MPP member and UiTM board member, they agreed to build the new court to increase the space for more students to play. Lately, the UiTM Samarahan volleyball female team are showing improvement in the competitions. Besides, they can use this new court to practice, and also they can use this court to help a competition among universities. And lucky for the UiTM students, the members of MPP succeed in getting a sponsorship from Sarawak Energy Berhad to build this new court. And this court has a rectangular shape and it has a volume of 22.5 meter per cube. The width and length is represented by x, which means both width and length have the same value, and the height is represented by h. And then the cost to build this new court is, for the top and bottom, is 100 ringgit per meter square for the side.
Next, I'm gonna talk about the problem statement for this project. As the introduction has mentioned about to build a new volleyball court, so the question is what to solve. However, to build such a new court, surely it's going to be pricey. The ATM higher ups and MPP discussed and agreed to only use the sponsorship money in the new court project construction. In order to make sure they can build the new court with only the sponsorship money, they need to find the minimum cost to construct it so the cost would not exceed from the actual budget. This is how it looks like for the dimension of volleyball court. Moreover, the objective for this project is to maximize the dimension of the volleyball court and find the minimum cost to build a new court by using the maximum or minimum of differentiation method.
Now I'm going to explain to you how to solve the problem that was given.
Okay, now I'm going to explain to you how to solve it. First of all, we're gonna put the given info that was in the problem statement, which is the volume, which is 22.5, and volume is also x squared h equal 22.5. Now we're gonna make h the subject, which is we of course divided it by x squared. So h equal to 22.5 over x squared. To find the cost material, which is C, we're gonna have to times the cost material times with area of top plus area of bottom, which plus with the cost material times with area of the four sides, because of it's a prism, obviously. Not to forget the area for top and area for bottom. The cost material is Rm 100 per meter squared, and area for the sides is Rm 80 per meter squared. Now we're going to substitute the value of cost into the equation that were given just now, which is Rm 100 times with x2 plus with x2 plus with Rm 80 times with 4xh. As we have to, this is the area of for the sides, and this is the area of top, and this is the area of bottom. After substituting in, or we multiplying in the value, we will get Rm 200 x squared plus with Rm 320 xh. Now we're going to substitute in the value of h, which we get at the beginning, which is h equals to 22.5 over x squared. We're going to substitute it in, which we will get Rm 200 x squared plus with 320 x 22.5 over x squared. We can cancel out the x, and we will multiply in the value, and we will get Rm 200 x squared plus 7200 x. This is the final equation for the cost. I repeat, the final equation for cost is Rm 200 x squared plus 7200 x is the final equation for cost. To minimize the cost, we will have to derive the equation, which is dc over dx equals 0. And after we derive the equation, we will get 400x minus 7200 x squared. We will get 400x minus 7200 x squared equals 0. To make x the subject, we will have to multiply all of it with x squared. After multiplying with x squared, we will get 400 x cubed minus 7,200 equals 0. We will need to make 400 the x equals subject. We will get 400 x cubed equals 7,200. Divide it with 400. The x cubed will become 7,200 over 400, and we need to cube root it. We will get x equals to 2.62. Therefore, this is the minimum cost for x. To make sure that the construction cost is really minimum, by using the value of x equals to 2.62, we will need to derive again the equation, which is the second derivative. We will get 2 squared over c over dx squared. We'll get 400 plus 14,400 over x cubed. We need to substitute in the value of x, and the value that we get is more than 0. Therefore, the construction cost is minimum. To find the minimum cost, we will need to substitute the value of x into the equation of c, which is c equals to Rm 200 x squared plus 7,200 over x, and the value of x is 2.62. We need to substitute it in, and it will become Rm 200 2.62 squared plus with 7,200 over 2.62. After calculating it, the final value is the final cost, or the final minimum cost is Rm 4,121.
Last but not least, I am Najwa is going to present the last part of the vid, which is the conclusion. As we can see here, by using the application of differentiation, which is the max and min problem, we can find the minimum cost of the new court. The top material part will cost 100 ringgit each, meanwhile the side material part will cost 80 ringgit each. So, the minimum cost in total will be 4,121 ringgit, and it is still in the actual budget range. So, here we can say the objective was achieved. Besides, the new court will be much bigger and able to accommodate more students than the old one. Next, UiTM Samarahan volleyball female team can use the court to freely practice and improve their skills for upcoming games. In addition, several volleyball competitions among universities can be held there, as we now can provide 2 courts for the game so that 2 rounds consist of 4 teams can be conducted at the same time. This factor fortunately can lead for the competition process going smoothly. For future improvements, as the new court will be an open field, it can also be upgraded to a covered one in future. With this improvement, students will still be able to play and use the court whenever it rains. Other sport facilities can also be improved, such as the football field and badminton court, that can also be improved by using the same application of differentiation method. These upgraded facilities can bring benefits for both students and the ITM higher ups, including the MPPR members, as students have more place to do physical activities such as playing badminton, football, and so on, to become more productive, to release their stress in studying, and also your ITM at the same time is trying to take care of the students' welfare. The accomplishment of getting sponsorship also can be succeeded this time to help in find the funding for the next improvement projects. So in the next slide, we will show our future improvement sketch for a covered field one. So we will put the roof and so on. I think that is all from us, and thank you for watching. Thank you, Miss. Thank you, Miss Jong. And thank you, everyone. See you guys so soon.